So in the last video lecture we discussed about the basics of dimensional analysis and their importance in conducting physical experiments. Okay, so before we move on to the actual discussions of how to obtain non-dimensional representation from the dimensional form, in this video lecture we will discuss some fundamental concepts that you already know. Then we introduce an important theorem called Buckingham Pi theorem. Okay, let us start with units and dimensions. Okay, so there are two types of quantities. Okay, so let us say if you consider a bag full of tennis balls. Okay, consider a bag with tennis balls, for example. Okay, there are two kinds of quantities. Okay, quantities that are counted. Okay, for example, the number of balls in the bag. Okay, so these quantities will have no units. Okay, so number of balls in the bag is just a number, will not have any units. Second one, quantities that are measured. Okay, so example, total mass of the bag. Okay, for it, so this will have appropriate units. Okay, the elementary form of measurement is to compare the quantity with the reference value. Okay, so by measurement or any type of measurement that you take, what we are talking about is to compare the quantity with an existing reference value that we have set. Okay, for example, we defined what 1 kg is, or 1 kilogram is. That is the reference value to measure mass, and the mass of any object is measured with respect to this reference value. Okay, so this unit is a human invention. Okay, but the dimensions are more fundamental. Quantity dimensions are more fundamental than units. Okay, and is independent of unit system. Okay, so you mentioned that the reference value is always coming into picture here, and different unit systems, when you say SI system or any other British system, so what is different is the reference value. So different unit systems have different reference values. Okay, in SI units, the reference for measuring the mass is 1 kilogram. In other system it can be 1 pound. Okay, so it is this reference value that differentiate different system of units, but dimensions are independent of the unit system. Okay, you know that there are 3 primary dimensions, right? So it is mass, length, time, okay, temperature, and amount of matter, and amount of light. Okay, the last one is electric current. Okay, this second batch is not our interest. We'll be talking only about this in the course. Okay, mainly with the first 3, maybe with temperature. Okay, and all other quantities can be expressed in terms of these primary dimensions. Okay, for example, if we take pressure, or let's start with force. We say force is mass times acceleration. So mass dimensions is m, acceleration is length t minus 2. Okay, so for pressure, for example, would be force per area. So we need to divide this by length square, so that will be m l minus 1 t minus 2. Okay, so dimensions of any other quantity can be expressed in terms of this primary dimension. So it can be viscosity, surface tension, anything can be written in terms of these primary dimensions. Okay, and then a very important one which you already know from your school days is the principle of dimensional homogeneity. Okay, do you remember what this principle is? Okay, so this says that for any expression that relates variables of a physical phenomena, all additive terms in the equation should be the same, should have same dimensions. So all additive terms in the equation should have same dimensions. Okay, so for example, let us take Bernoulli's equation. What we have is P plus half rho u square plus rho g z to be constant. Okay, so all of them including the constant should have units of, should have same dimensions. Okay, so you know this already. At any point of time, if you come across an equation, or if you are doing an analysis and you get an equation that is not satisfying this dimensional homogeneity principle, that simply means that your analysis is wrong. Okay, it is not possible to have an expression that does not satisfy dimensional homogeneity and express a physical relationship. Okay, it just says that we cannot add apples and oranges. Okay, and if in terms of units we go one step further, if we write this in terms of units, then all additive terms should have the same units. So if one is Newton per meter square, another also should be newtons per meter square, not kilonewton per meter square. Okay, so this you already know from your high school physics itself. Okay, now we are going to introduce an important theorem based on which we will perform all non-dimensionalization. Okay, it's called Buckingham Pi theorem. Okay, so it's written like this: if a physical process has n dimensional variables, okay, and that involve m number of primary dimensions, then it can be rewritten as n minus m non-dimensional terms. Okay, so let us consider the drag example. Okay, so the drag on sphere is a function of rho u d mu. Okay, so the number of dimensional variable is 5. Okay, 1 2 3 4 5, and the number of primary dimensions is 3. Okay, which is m, l and t. Okay, you write all these expressions, you get that the number of primary dimensions is, other than mass, length and time, none of the variables involve any other dimensions. Okay, so the number of non-dimensional units, so the number of non-dimensional terms is n minus m that is equal to 2, which is what we have written earlier. Rho u square t square is a function of d by u. Okay, so this is non-dimensional unit 1 and this is non-dimensional number 2. Okay, so Buckingham Pi theorem says that a physical process can have n dimensional variables. In this case it is 5 that involve m number of primary dimensions. Okay, the number of primary dimensions here is mass, length and time. Neither temperature or amount of light or any other dimension is involved here, and then so the total number of non-dimensional term would be 2. Okay, so the non-dimensional group obtained are independent. By independent we mean one cannot be formed as combination of others. Okay, and these independent groups are called pi terms. Okay, these independent non-dimensional groups are called pi terms. Okay, so we will use this Buckingham Pi theorem to actually arrive at the non-dimensional form from dimensional form, which we will discuss in the next class.